Welcome to this comprehensive video where we will delve into the core and essential concepts of RabbitMQ, one of the leading message brokers in the industry. By understanding these fundamental concepts, you will gain a solid foundation for building robust and scalable messaging solutions. We will cover the following key concepts in RabbitMQ. Broker. The broker serves as the central component of RabbitMQ, responsible for receiving messages from producers and routing them to the appropriate consumers. Understanding the role and functionality of the broker is vital to comprehending the inner workings of RabbitMQ. Producer. Producers are entities that generate and send messages to the RabbitMQ broker. We will explore how producers interact with RabbitMQ, including message publishing, specifying headers and properties, and ensuring reliable delivery. Connection. A connection represents a connection between a client application and the RabbitMQ broker. We will discuss how connections are established, managed, and utilized in RabbitMQ, enabling efficient and reliable communication. Channel. Channels are virtual connections within a connection that facilitate message publishing, consuming, and acknowledgements. We will explore the benefits of channels, their configurations, and how they optimize message handling. Prefetch. Prefetch settings determine the number of unacknowledged messages that can be delivered to a consumer. We will dive into prefetch configurations and understand how they influence message consumption and processing. Messages. Messages form the core data units in RabbitMQ. We will explore the anatomy of messages, including headers, properties, and payload. Understanding the structure and components of messages is crucial for effective message handling. Exchanges. Exchanges receive messages from producers and route them to the appropriate queues. We will explore different types of exchanges, their properties, and how they enable flexible and efficient message routing. What is a broker? A broker in RabbitMQ is a message broker or an intermediary that receives messages from producers and routes them to consumers. It acts as a middleman for message communication. What is inside a broker? Inside a broker, there are several key components. Message queues. Queues hold the messages until they are consumed by the intended consumers. Exchanges. Exchanges receive messages from producers and route them to the appropriate queues based on routing rules. Channels. Channels are virtual connections within a connection. They handle message publishing, consuming, and acknowledgements. Connections. Connections represent a connection to the RabbitMQ broker from a client application. How brokers scale. RabbitMQ brokers can scale horizontally by adding multiple broker instances to form a cluster. Each broker in the cluster shares the message load, improves fault tolerance, and provides high availability. Load balancing mechanisms, such as consistent hashing or round-robin, distribute messages across brokers in a cluster. How brokers can connect to each other. Brokers can connect to each other using a mechanism called clustering. Clustering allows multiple RabbitMQ instances to form a single logical broker. Brokers communicate and replicate message and queue information across the cluster, ensuring that messages are properly routed and queues are synchronized. By connecting brokers in a cluster, you can achieve fault tolerance, load balancing, and scalability in RabbitMQ deployments. A producer is an application or component responsible for generating and sending messages to a RabbitMQ broker. It plays a crucial role in the messaging system by producing the data or events that need to be communicated. Here are the key points to understand about producers. Firstly, a producer generates messages to be sent. These messages contain the information or data that needs to be communicated to other components or consumers. Once the messages are generated, the producer sends them to a RabbitMQ broker. The broker acts as an intermediary, receiving the messages from the producer and routing them to the appropriate consumers. It's important to note that a producer can be any application or system capable of producing and sending messages. It could be a web application, a sensor device, a back-end service, or any other component within a distributed system. When a producer sends messages to RabbitMQ, it typically sends them to exchanges. Exchanges are responsible for further routing of the messages to the appropriate queues based on routing rules. A connection represents a connection between a client application and the RabbitMQ broker. Here are the key points to understand about connections. Creation. To establish a connection, client applications use RabbitMQ client libraries or tools that provide connection capabilities. Variations. Different programming languages and frameworks have their own libraries for creating connections to RabbitMQ. This allows developers to choose the most suitable library for their application. Configuration. When creating a connection, various settings can be configured. These include specifying the RabbitMQ broker's host, port, credentials, username and password, and virtual host. These settings ensure that the client application can connect to the correct RabbitMQ instance. Properties. Connections can also have properties that determine their behavior. For example, properties like heartbeat interval and connection timeout can be set to manage the connection's health and responsiveness. Connections play a crucial role in establishing communication between the client application and the RabbitMQ broker. They serve as the entry point for producing and consuming messages. In this Python code, we are using the Pika library, which is a popular RabbitMQ client library for Python. The code demonstrates different variations, configuration options, and properties that can be used when creating a RabbitMQ connection. Basic connection creates a connection to the RabbitMQ broker running on the localhost using default connection parameters. Connection with configuration specifies additional connection parameters such as host, port, virtual host, and credentials. Connection with properties sets specific properties for the connection, such as heartbeat interval and block connection timeout. Connection with SSL/TLS configures the connection to use SSL/TLS for secure communication with the RabbitMQ broker. SSL options such as version, certificate paths, and certificate requirements are provided. Finally, the code closes the connection when it's no longer needed. This example showcases how connections can be created and customized according to your requirements in Python using the Pika library. The code uses the mplib library, a popular RabbitMQ client library for Node.js, to create a RabbitMQ connection. The connection URL variable specifies the URL of the RabbitMQ broker. In this case, it is set to amp//localhost, assuming RabbitMQ is running locally. The connection options variable holds the configuration options for the connection. It includes the username and password for authentication, as well as the heartbeat interval and connection timeout values. The createConnection function is defined as an async function that creates a RabbitMQ connection using amp.connect method. It takes care of error handling as well. Inside the createConnection function, you can perform any desired actions with the connection, such as publishing messages or consuming messages. Finally, the code closes the connection using connection.close. This sample code demonstrates the basic creation of a RabbitMQ connection using the mplib library in JavaScript. You can customize the connection options and perform additional actions based on your specific requirements. Note: make sure to install the mplib library by running npm install mplib before executing the code. A channel represents a virtual connection within an actual connection to the RabbitMQ broker. Here are the key points to understand about channels. Creation. Channels are created within a connection, allowing multiple virtual connections to exist within a single physical connection to the broker. Client libraries or tools provide methods to create channels. Variations. Different programming languages and frameworks offer their own libraries for creating RabbitMQ channels. These libraries provide language-specific methods and functionalities to interact with channels. Configuration. Channels can be configured with various settings to control their behavior. For example, you can set the prefetch count to limit the number of unacknowledged messages a channel can have, or enable channel flow control to manage the flow of messages. Properties. Channels have properties that provide additional information. Each channel is assigned a channel number that helps in identifying and managing channels. Channels can also be set to operate in transactional mode, ensuring message transactions are atomic and consistent. Channels play a significant role in RabbitMQ messaging. They handle message publishing, consuming, and acknowledgements. They allow for efficient communication and provide flexibility in managing message flows and transactions. Remember that channels are created within a connection, and multiple channels can coexist within a single connection. The Pika.blocking connection class is used to establish a connection to RabbitMQ using the specified connection parameters. The channel object is created using the channel method on the connection object. This creates a new channel within the established connection. The channel.basic_QoS method is used to configure the channel. In this example, the prefetch_count is set to 10, which limits the number of unacknowledged messages a channel can have at a time. After creating and configuring the channel, you can perform various actions on the channel, such as declaring queues, exchanges, and publishing or consuming messages. Finally, the code closes the channel and the connection using the channel.close and connection.close methods, respectively. The createChannel function is defined as an async function that creates a channel within a connection using connection.createChannel method. It takes care of error handling as well. Inside the create channel function, you can perform any desired actions with the channel, such as declaring queues, binding exchanges, or consuming messages. Finally, the code closes the channel and connection using channel.close and connection.close. Prefetch refers to the ability to limit the number of unacknowledged messages that a channel can have before it stops consuming more messages. Here are the key points to understand about prefetch configuration. Purpose. The purpose of prefetch is to avoid overloading consumers with too many messages at once. By setting a prefetch limit, we can control the number of messages that a consumer can prefetch and process at a given time. Configuration. To configure prefetch in RabbitMQ, we can use the channel.prefetch method provided by client libraries. This method allows us to specify the maximum number of unacknowledged messages that a channel can have. Practical considerations. When setting the prefetch count, it's important to consider the consumer's processing capacity and the message workload. Setting a value that aligns with the consumer's capability ensures efficient message processing without overwhelming the consumer. Prefetch configuration plays a crucial role in balancing the workload and ensuring efficient message consumption in RabbitMQ. By setting an appropriate prefetch value, we can optimize the performance of our consumers and ensure a smooth message flow. Inside the with block, a connection is created using pika.blocking connection, and a channel is created using connection.channel. The prefetch_count variable is set to the desired prefetch count. Adjust this value according to your requirements. The channel.basic_QoS, prefetch_count equals prefetch_count, method is used to configure prefetch. This sets the prefetch count on the channel. You can perform any desired actions with the channel within the with block. Finally, the channel is closed using channel.close. Here's a full example in JavaScript that demonstrates how to configure prefetch in RabbitMQ using the channel.prefetch. A connection is established using emp.connect, and a channel is created using connection.createChannel. The prefetch count variable is set to the desired prefetch count. Adjust this value according to your requirements. The channel.prefetch, prefetch count, method is used to configure prefetch on the channel. You can perform any desired actions with the channel within the function. Finally, the channel and connection are closed using channel.close and connection.close. Messages are the fundamental units of data that are sent and received within RabbitMQ for communication between producers and consumers. Here are the key points to understand about messages. Definition. Messages represent the data that is exchanged between producers and consumers in RabbitMQ. They contain the information to be processed and delivered. Publish normal messages. Producers publish normal messages to exchanges. These messages are then routed to appropriate queues based on the routing rules defined by the exchanges. Publish RPC messages. Producers can also publish RPC, remote procedure call, messages. These messages include additional fields like correlation IDs and reply to fields to enable request-response communication patterns. Headers. Messages can have headers that provide additional metadata or information about the message. Headers can be used for custom routing or processing logic. Properties. Messages have properties that provide important details about the message. Properties can include the content type, expiration time, delivery mode, and more. These properties help in handling and processing messages appropriately. Payload. The payload of a message contains the actual data being transmitted. It represents the information that needs to be consumed or processed by the receiving application. Message properties provide additional metadata and control over how RabbitMQ handles the message. The properties include Message ID. The message ID is a unique identifier assigned to each message published in RabbitMQ. It helps to uniquely identify and track messages within the system. Message IDs are typically generated by the publisher or can be assigned by RabbitMQ itself. Content type. The content type property indicates the MIME type of the message payload. MIME types are standardized identifiers that describe the nature and format of the data being transmitted. For example, common content types include application/JSON for JSON data, text/plain for plain text, image/JPEG for JPEG images, and so on. The content type property helps consumers to interpret and handle the message payload appropriately. Content encoding. The content encoding property specifies the encoding used for the message payload. Encoding refers to the process of transforming data from one representation to another, such as converting text from UTF-8 to ASCII or compressing binary data. RabbitMQ supports various encoding mechanisms, including standard encodings like UTF-8, ASCII, and binary encodings like base64. The content encoding property allows the consumer to correctly decode and process the message payload. Delivery mode. The delivery mode property indicates whether a message should be persisted or considered transient. When a message is marked as persistent, RabbitMQ ensures that it survives broker restarts or failures by saving it to disk. On the other hand, transient messages are not persisted and will be lost if the broker restarts or fails. The delivery mode property is useful when messages need to be reliably stored and delivered, especially in scenarios where data loss is not acceptable. Timestamp. The timestamp property represents the time at which the message was sent by the publisher. It provides a reference point for tracking the age of the message or determining its freshness. The timestamp can be useful for monitoring message latency, performing time-based processing, or implementing various time-related business logic. Expiration. The expiration property specifies the message's expiration time, after which it becomes stale and should not be delivered or processed. This property is particularly useful when messages have a limited lifespan or when there is a need to enforce time-based constraints on message consumption. Messages that have expired can be discarded by RabbitMQ or can be routed to a designated, dead letter, queue for further analysis or processing. Priority. The priority property indicates the relative importance or priority level of a message. It allows messages to be prioritized and processed in a specific order when multiple messages are waiting to be consumed. Heirs and consumers to exchange additional information about the message. RabbitMQ supports message prioritization based on an integer value assigned to the priority property. Higher priority values indicate greater importance, and RabbitMQ can be configured to prioritize the delivery of messages with higher priority over lower priority ones. Headers. Headers are custom application-specific metadata that can be included in a message. They allow publishers and consumers to exchange additional information about the message beyond the standard properties. Headers can be used to convey specific details or instructions related to the message processing, routing, or filtering. For example, headers can be used to indicate message versioning, origin, specific processing requirements, or any other application-specific context relevant to the message. Headers provide flexibility and extensibility to the messaging system, enabling tailored behavior based on the specific needs of the applications involved. The headers in RabbitMQ messages are application-specific and can be defined based on your specific requirements. There is no predefined list of headers in RabbitMQ as they can vary depending on the needs of your application. You can define any custom headers that provide additional information or instructions for message processing, routing, or filtering. Here is an example of some commonly used custom headers that applications may define. Authorization, used to indicate the authentication or authorization credentials associated with the message. Correlation ID, a unique identifier used to correlate related messages or message sets. Message type, specifies the type or purpose of the message, allowing consumers to differentiate between different types of messages. Retry count, keeps track of the number of times a message has been retried or attempted to be processed. Error handling, contains error information or instructions for handling errors associated with the message. Routing information, additional routing details or instructions that can be used by exchanges or queues for message routing. Versioning, indicates the version of the message or data schema used, allowing for backward compatibility or version-specific processing. Custom metadata, any other application-specific metadata or context that needs to be conveyed with the message. Remember, these are just examples, and the actual headers you use will depend on the specific needs and design of your application. You are free to define any custom headers that provide value and serve your application's requirements. In this example, we use the Pika library to establish a connection and channel with RabbitMQ. The exchange_declare method is used to declare the exchange. The Pika.basic properties class is used to define the message properties, such as headers, correlation ID, content type, delivery mode, app ID, expiration, and more. The message variable holds the actual payload of the message. The basic_publish method is used to publish the message with the specified exchange, routing key, body, payload, and properties. This code example demonstrates how to include headers, properties, and payload with a message in RabbitMQ using Python and the Pika library. Note, make sure to install the Pika library by running pip install Pika before executing the code. We begin by defining the properties of the message. These properties provide additional metadata and control over how RabbitMQ handles the message. In our example, we have specified the following properties. Headers. We include an authorization header with the value bearer XYZ123. This header can be used to provide authentication or authorization credentials. Correlation ID. The correlation ID is set to ABC123. It helps in correlating related messages or message sets. Content type. The content type is set to text/plain, indicating that the message payload is plain text. Delivery mode. The delivery mode is set to 2, which means the message is persistent and will survive a broker restart. App ID. The app ID is set to my_app, allowing the consumer to identify the application that published the message. Expiration. The expiration is set to 3600000, indicating that the message will expire after 3600000 milliseconds, 1 hour. The connection and channel setup code is not shown in this slide for brevity. This includes establishing a connection to RabbitMQ, creating a channel, and asserting the exchange in queue. Finally, we publish the message using the channel.publish method. We provide the exchange name, my_exchange, and the routing key, my_queue, to specify where the message should be delivered. The message itself is passed as a buffer, which is created using buffer.fromMessage. Additionally, we pass the properties object to include the defined message properties. Now, let's explore the concept of exchanges in RabbitMQ. Exchanges are the entities responsible for receiving messages from producers and routing them to queues based on specified rules. Here are the key points to understand about exchanges. Definition. Exchanges serve as the routing mechanism in RabbitMQ. They receive messages from producers and determine which queues should receive the messages based on specified rules. Types of exchanges. RabbitMQ supports different types of exchanges to accommodate various routing scenarios. Direct exchange routes messages to queues based on a matching routing key. Fanout Exchange routes messages to all queues bound to the exchange, regardless of the routing key. Topic exchange routes messages based on wildcard patterns in the routing key. Headers exchange routes messages based on header attributes matching specified criteria. Properties. Exchanges have several properties that can be configured. Name. Each exchange has a unique identifier or name. Type. The type of exchange determines the routing behavior. Durability. Specifies if the exchange survives a broker restart. Auto-deletion. Determines if the exchange should be deleted when it's no longer in use. Arguments. Additional parameters specific to the exchange type can be provided. Now, let's discuss the concept of a direct exchange in RabbitMQ. A direct exchange is a type of exchange that routes messages to queues based on a matching routing key. Here are the key points to understand about direct exchange. Definition. Direct exchange is a type of exchange in RabbitMQ that routes messages to queues based on a matching routing key. It provides a one-to-one relationship between queues and routing keys. Routing key. When a message is published, it is associated with a routing key. Queues are bound to the direct exchange with specific routing keys. Exact match. Messages with a routing key matching the binding key of a queue are routed to that specific queue. Direct exchange performs an exact match between the routing key and the binding key of the queues. One-to-one relationship. In direct exchange, each queue is associated with a specific routing key. This enables a direct mapping between routing keys and queues. Routing flexibility. Direct exchange provides flexibility in message routing based on specific routing keys. It allows for fine-grained control over which messages are routed to which queues. Direct exchange is commonly used when you want to route messages based on specific criteria or routing keys. It offers more precise control over message delivery. A fanout exchange is a type of exchange that routes messages to all queues bound to the exchange. Here are the key points to understand about a fanout exchange. Definition. A fanout exchange is designed to broadcast messages to all queues bound to the exchange. It provides a mechanism for one-to-many message distribution. Broadcasting. When a message is published to a fanout exchange, it is broadcasted to all queues bound to the exchange. The message is duplicated and delivered to each bound queue. Ignoring routing keys. Unlike other exchange types, a fanout exchange ignores routing keys specified during message publishing. It indiscriminately sends messages to all bound queues. One-to-many relationship. A fanout exchange can have multiple queues bound to it, resulting in a one-to-many relationship. Each queue receives a copy of every message. No routing flexibility. Fanout exchange does not provide routing based on specific criteria or keys. It is primarily used for broadcasting messages to multiple consumers. A Fanout Exchange is commonly used in scenarios where you want to distribute the same message to multiple consumers or queues without any filtering or selection criteria. A topic exchange is a type of exchange that routes messages based on wildcard patterns in the routing key. Here are the key points to understand about a topic exchange. Definition: a topic exchange routes messages based on wildcard patterns in the routing key. It allows for flexible and granular routing based on patterns. Routing key patterns. When a message is published, it is associated with a routing key. Queues are bound to the topic exchange with specific routing patterns. Wildcard matching. Topic exchange uses two wildcard characters to match routing patterns. Asterisk matches exactly one word in the routing key. Hash matches 0 or more words in the routing key. Flexible routing. With topic exchange, you can define routing patterns using wildcards to specify which messages should be routed to specific queues. This provides flexibility in routing based on patterns in the routing key. One-to-many relationship. Multiple queues can be bound to a topic exchange with different routing patterns. This allows for one-to-many relationships between exchanges and queues. A topic exchange is commonly used when you want to route messages based on specific patterns or topics. It provides a versatile routing mechanism that enables selective message delivery. A headers exchange is a type of exchange that routes messages based on header attributes matching specified criteria. Here are the key points to understand about a headers exchange. Definition: a headers exchange routes messages based on header attributes matching specified criteria. It allows for complex routing logic based on header values. Header matching. Messages are matched based on the values of their header attributes. The exchange compares the headers of the message with the criteria specified during binding. Criteria. The headers exchange matches messages based on specific criteria defined in the bindings. The criteria can include matching header attribute names and values. No routing key dependency. Unlike other exchange types, headers exchange does not rely on routing keys for message routing. It solely depends on header attribute values. Complex routing logic. Headers exchange provides flexibility for complex routing scenarios that cannot be achieved with routing keys or patterns. It allows for fine-grained control over message routing based on header attributes. A headers exchange is commonly used when you need to perform advanced routing based on custom header attributes associated with the messages.
The code declares exchanges of different types in RabbitMQ. Direct exchange, messages are routed based on a matching routing key. Fanout exchange, messages are broadcasted to all queues bound to the exchange. Topic exchange, messages are routed based on wildcard patterns in the routing key. Headers exchange, messages are routed based on header attributes matching specified criteria. After declaring each exchange, a success message is printed indicating the successful creation. This code demonstrates publishing a message to a direct exchange in RabbitMQ using the Pika library. The Pika library is imported to provide the necessary functionalities for interacting with RabbitMQ. Connection_params is an object that stores the connection parameters, including the hostname, localhost, and the credentials, guest. The publish_message function is defined to publish a message to the direct exchange. Inside the function, a connection and channel are created using Pika.blocking connection and connection.channel. The direct exchange is declared using channel.exchange_declare with the exchange name my_direct_exchange and the exchange type direct. A message to be published is assigned to the message variable, hello, RabbitMQ. A routing key, which serves as a message attribute for routing, is assigned to the routing_key variable, my_routing_key. The channel.basic_publish method is used to publish the message to the direct exchange. The exchange, routing key, and message body are provided as parameters. A success message is printed to indicate that the message has been published successfully. Finally, the channel and connection are closed using channel.close. This code snippet demonstrates the process of connecting to RabbitMQ, declaring a direct exchange, and publishing a message to the exchange with a specific routing key. Note, before running the code, ensure that the Pika library is installed by running pip install Pika. This code demonstrates the process of publishing a message to a direct exchange in RabbitMQ using the amplib library in JavaScript. Amp.connect, connection params, establishes a connection to the RabbitMQ server using the specified connection parameters, connection params. Connection.createChannel, creates a channel within the connection for message publishing. Channel.assert exchange, exchange name, exchange type, declares the direct exchange with the specified name, exchange name, and type, exchange type. Channel.publish, exchange name, routing key, buffer.from, message, publishes a message to the direct exchange. The message content is defined in the message variable, and the routing key is specified as routing key. Console.log outputs a success message indicating that the message has been published with the given routing key. Channel.close and connection.close close the channel and connection respectively to release resources.